So um, if you can see in the screen, I'm right now on the website of Flow Waterjet, the company who designed this, let's say, mm, device, okay?
Products.
Product or device. Now, as you can see on the website, we're gonna make just a quick reading about this waterjet. In the website, they told us about the basics, and it says the basics. The concept of waterjet is quite simple. Here, how it works. And now it has three parts. The first one is generate pressure. The second one is to convert pressure into velocity. And last one is to introduce the garnet. You might remember that sometimes they use just water to make the cuts, to make the cutting. But sometimes if they want to cut something more thick, something more hard, any kind of iron or something like that, of course, they can use water, but if they want to make it a little bit quicker, they can use a garnet, like an additive or a powder, to, in this case, increase the cut, the force cut, okay, the cut force.
Okay.
So the three basics in the water jet are to generate pressure, and it says an ultra high pressure pump generates a stream of water with pressure rated up to 94,000 psi. Then it converts that pressure into velocity via a tiny jewel orifice, creating a stream as small as a human hair. You see? And then introduce the garnet, the powder, this additive. It says that the garnet increase the cutting power by 1,000 times. And the garnet is pulled into the supersonic water jet stream. Okay. I don't know if you, I suppose you have been to the beach. So I don't know if you have had the opportunity to be hit by a wave, that you are in the line of the beach, like near the coast, you're sitting on the sand, and suddenly it strikes you one big wave. And when the water hits you with sand, you feel like your, in this case, that your skin feels like itchy. That means that you want to scratch and it turns red because of the heat of the water with sand. It's something similar, okay? When you combine water and a garnet, in this case, when you go to the beach, the water combines with the sand. And in this case, the speed, the velocity of the wave, when it impacts you, then you feel like itchy and you turn red because of the impact. So it's something similar that happens in here. They combine water with the garnet to have more power to cut. Okay. So you have this, it says per water jet, abrasive water jet, with the help of the garnet, of course. Okay, and then you have the components. It says a water jet is more than just pressurized water and sand. The shape cutting system is comprised of the ultra high pressure system, the machine, and the control system. Okay, that's all the water jet by
The
itself.
sources.
Okay, that in this case you need them to operate it. The programming software, the interface, the drive motors, the velocity feedback system, and stuff like that. And they have different water jets actually. Okay, they
In this
work with different machines.
in this case, this process is very modern, very modern, no?
Yeah.
Because before, in early times or early times, this class of machines and it's not very similar. Well, it's not was very similar.
It wasn't so similar, yes.
Yes. So I see that this class of machines has an accessories, a new accessories, and maybe there are several brands with this in this class machine. No, well, it's interesting that this process you comment about the you can apply with water or sand. This kind of, due to
You
the
combine
garnet.
them.
It's interesting, very interesting uh, for that process, no?
Exactly. I'm gonna show you a 2-minute 40 seconds video about the water jet cutting, okay? I don't know if you're gonna see it quite fluent, the video, but I activate the subtitles, okay?
Okay.
So that you can also quite read it a little bit better. Let me use a hide letter like this so that it's easier for you to read it. So look at the video and let's see what you got in here.
Hi there. eMachine Shop offers water jet cutting to make quality parts for you quickly and economically. Water jet cutting can cut almost any type of material, and it has no adverse effects from heat at edges. With minimal setup costs, even low quantities are economical. Of course, we can also accommodate any production needs you might have. In this video, I'll show you the water jet process. We're currently cutting through an aluminum sheet to produce multiple parts. Notice how the jet turns on and off. The nozzle is the metal part that the water flows through. The water is at an extremely high pressure of 50 to 60,000 psi. We are showing 2 parts cut in a run of 100 parts. These are what the parts look like after they are cut. As the parts are being cut, the computer system shows a detailed map tracing the cutting path so the operator can follow the process. The purple lines indicate cut lines. The green lines are called traverses. Traverses are where the head moves without cutting so it can jump, typically from a cutout to an outer contour, or between one cutout and another, or between holes. You'll also notice that the movement slows as it comes to the corners. The computer automatically figures out the best way to move the jet to make a perfect part. At this point, we are cutting the second part of the outer contour, and then the traverse. In order for water to cut through metal up to several inches thick, the water is mixed with an abrasive. The water abrasive mixture proceeds down through a tube to the cutting head. The high pressure is created by a sophisticated pumping system that generates about 50 to 60,000 psi. The tube on the right stores the high pressure water that goes to the cutting head. Thanks for watching. We look forward to making parts for you and welcome any questions you might have. We welcome existing CAD files for quotation, or you can use our unique and free eMachine Shop CAD software. eMachine Shop allows you to design your parts quickly and easily, receive instant design feedback, get instant pricing, and order online. Bye for now.
Okay, so that was a short video about the water jet, okay, just for you to close up this term, okay, in this part of the unit. So now on, let's move to our next topic in here. And for this one, I'm gonna change you to my PowerPoint presentation just for a small introduction.
Okay.
Okay, in this part, it says explaining jointing and fixing techniques. The idea of this unit, of this section, you might remember that in the first and second part, we have been working with description of the components. Then we work with explaining the assessing and manufacturing techniques. That means how you do something, okay? And in this third part, now you need to explain how those components that we work in the first part of the unit, you are going to fix them together. How are you going to, in general colloquial language, how are you going to paste them, to put them together? So the main idea of this section is to look at the ways of affixing components together to form assemblies, representing a logical extension of the previous section, previous section on the form in the machining individual components. Okay, that's the main idea of this part. And before we start, I want to give you something, a language note, okay? During this part, you will find the following vocabulary useful, okay? So for you to got and remember them, you have the words such as bolt, screw, rivet, clip, weld, adhesive, bond, glue, join, connect, and the phrases fix to, fix on, fix onto, and fix together. I don't know if there's a word that you do not understand so that I can give you the idea of the translation. Or do you understand or know the meaning of all the different concepts?
I have my doubts in bond.
In which one?
Bond.
Bond, like James Bond. Bond, in this case, you know as the connection between one component and another. Okay, for example, let me think of a sentence talking about engineering. Okay, for example.
Maybe it can be like a link.
Yes, a link.
Yes.
In general cases, for example, a bond of oxygen and hydrogen forms water. The combination of oxygen and hydrogen forms water, a bond, okay, like an enlace, una unión. You can find synonyms, for example, adhesive, bond, glue, join, and connect. These 5 words are synonyms because
what's the difference? And so what's the difference bond and join?
Bond and join. The difference in here, of course, it depends of the component. Okay, it depends a lot of the component material, or if you're talking about a component or a part, it has to do with that. For example, bond means to connect, for example, to secure something, to tie with a bond, okay? And join means to combine more than one item, okay? That means to put together. Okay, I don't know if you quite understand that.
The idea is try to get, join connection 1, join to connection 2. The idea is similar, but no is identical, or that when if I try explain with components, it's different that connect between join and bond, but is similar. The idea is similar, but no is totally same, no, or identical.
Yes, in this case, you can know bond, it's like the connection, but not a combination. Meanwhile, join, it's a combination. Okay?
Exactly. Yes.
I don't know if you got the idea, Josue?
Yes.
Okay, great. Now, let's move on. So this is some vocabulary that you might see a lot actually during this unit. So let's go ahead and let me go back just to the book to start this part. So I want you to think in some ideas, okay? Let me make a zoom for you to cut in here. I want you to think some examples of ways of joining materials. Okay, how can you join a material or a component if you want to? How can
Maybe
you
when
join them?
join them. Okay. You are talking about that alloys
Yes,
join
okay, that's
the
an
materials or
example.
mm,
Any ideas, for example? I don't know if, well, I know that you're in a room right now. You're having the class in a room. I want you to look around. Look around your room and try to identify one joint in a furniture, maybe a fixture, a fitting, in something that it's near you right now. For example, right now I'm sitting on a chair, on a wood chair, okay, on a wooden chair. So to make this chair, people paste, in this case, they put together, they glue, it's the verb, they glue different pieces of wood to make a chair. So right now I'm sitting in a component of jointing materials. I don't know about you. An example that you have?
Yeah, there are different assemblies in my room. Maybe it can be the desk. The
Okay.
desk when I have a wood with metal or aluminum,
Okay.
they are connected or joined with bolts. With the bolts, that kind of bolts are iron or steel or stainless with stainless material. I think it's one assembly, you know, with different materials.
Exactly. Yes, that's the main idea of this. Josue, any device, any maybe component jointing that you have near you?
Mechanical fixings and rivet, and that is similar, but the rivet is more with the deform something according to a force in any phase or something like that. So rivet is more common in aluminum and rivets or steel, including steel. And
in this case, in the
yes,
room that you're in now,
in could you repeat?
right now you're in a room having the class, no?
Yes.
Now around you, is there something that you can compare as a jointing or a joining? For example, I mentioned my chair. Juan mentioned his desk.
Yes.
Something that you say, this is a joining because they
Well,
paste, they weld, I don't know, something like that.
the first in my mind is the, have you ever been the Hot Wheels products in the bottom side? Do you remember? Has all Hot Wheels products has rivets when you can see made in Malaysia, made in Indonesia. So you can watch.
Okay, I quite got the idea in here. Thank you. So, talking about these different joining materials and stuff like that, we're going to have a listening part. You're gonna hear Pedro, a really Mexican. You're gonna listen Pedro. Pedro is a purchasing manager with a kitchen appliance manufacturer, and he is talking to Alicia. Alicia is a sales manager from the supplier. So you're going to listen to the conversation and try to answer the next 3 questions. Josue, could you please read question 1 and Juan question 2?
Okay.
What objective does Pedro describe regarding his company's relationship with suppliers?
Okay. The number 2 is, what is Alicia concerned about?
And third one, how does he respond to her concerns? Remember, concern, it's like preocupaciones, okay?
Okay.
So these 3 questions, you have to answer them with the conversation between Pedro, the purchasing manager, and Alicia, the sales manager, okay? So let's listen to the conversation quite carefully and try to answer the questions. Listen carefully.
Okay.
Point 8. So basically, our objective is to get key suppliers more actively involved in the design process. So rather than us going to a supplier and saying, we want a specific type of bolt or screw or rivet for connecting these components, can you give us a price? We want to be able to say, we need a way of joining this part to this part. What's the best way of fixing them to each other?
Okay.
So it might be that you say, well, actually, instead of bolting this onto the machine, what about using a weld? Or instead of riveting these, how about bonding them with adhesive or fixing them on with some kind of clip or whatever? Whatever's the most cost-effective solution.
Right. But obviously, we're a supplier of mechanical fixings, so we can only provide a mechanical solution. So, if you ask us to design some joints, which is obviously quite an involved job, and then, after all that, a rival firm comes along and says, well, we suggest welding it all together or gluing it together for half the price, it would mean a lot of work for no return. I'm not saying it's a bad idea. It's just that we would have to be careful we covered our costs.
I appreciate that, but the flip side is we want to work with fewer suppliers than we have in the past. So overall, that problem would be offset by the greater volume of work you'd get.
Okay. Do you need me to play it one more time?
Yes, I think so.
Remember, you're looking for the objective of Pedro describing this. What is Alicia concerned about? I mean, what's Alicia thinking would be the problem? And finally, how did Pedro, in the conversation, responded to her concerns? So listen to it.
3.8. So basically, our objective is to get key suppliers more actively involved in the design process. So rather than us going to a supplier and saying, we want a specific type of bolt or screw or rivet for connecting these components, can you give us a price? We want to be able to say, we need a way of joining this part to this part. What's the best way of fixing them to each other?
Okay.
So it might be that you say, well, actually, instead of bolting this onto the machine, what about using a weld? Or instead of riveting these, how about bonding them with adhesive or fixing them on with some kind of clip or whatever? Whatever's the most cost-effective solution.
Right. But obviously, we're a supplier of mechanical fixings, so we can only provide a mechanical solution. So, if you ask us to design some joints, which is obviously quite an involved job, and then, after all that, a rival firm comes along and says, well, we suggest welding it all together or gluing it together for half the price, it would mean a lot of work for no return. I'm not saying it's a bad idea. It's just that we would have to be careful we covered our costs.
I appreciate that, but the flip side is we want to work with fewer suppliers than we have in the past. So overall, that problem would be offset by the greater volume of work you'd get.
So, according to Pedro, the objective of this describing regarding his company's relationship with suppliers. what is the main idea? What is the objective of this? To
I
what?
think
What are
he
your
talked.
answers?
Well, in my case, I understand that he talked about the suppliers when the suppliers is I mean related with the design, and he specifically talk about mm, 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 different suppliers. I think is that the idea is the idea because he mentioned different I mean no links that just you mentioned that the adhesives or like a well or different connections
Okay.
using it for that suppliers, no?
Okay. And Josue,
I
what
think.
about you? Which one do you think it's the objective? By regarding his company's relationship with suppliers.
I don't know. I have my doubts. Pedro says or describe the different solution, mechanical solution, according to different fastener products in relationship, well, with suppliers.
Exactly. So everything has to do with suppliers, as you both said. So the objective in here is to involve their suppliers, okay, in what, well, in this case, more actively in design, in the design of the
Okay.
products that they want to buy. That's the aim of
Okay.
this conversation, okay, to involve their supplier more actively in design. That's Pedro's objective by describing regarding his company's relationship. So known as the last, number 2, it's what is Alicia concerned about? What's the problem? What will be the future problem that Alicia thinks about? Josue, I start with you.
I don't remember the main concerns.
No,
I think
Juan?
her mentioned that the cost with effective solution. She concerned about the cost and that maybe time of the job about suppliers.
Okay. Listen to this part again of the conversation and try to know what is Alicia concerned about.
Solution. So, if you ask us to design some joints, which is obviously quite an involved job, and then, after all that, a rival firm comes along and says, well, we suggest welding it all together or gluing it together for half the price, it would mean a lot of work for no return. I'm not saying it's a bad idea. It's just that we would have to be careful we covered our costs.
That's the part that she mentioned. That's Alicia's concern. And as you said, in this case, she's concerned about doing a lot of work, in this case, for no return. And also covering costs.
Okay,
covering cost. That's Alicia's concern, so that you can write it next to it. And in the last part, you need to know how did Pedro answer to these concerns? I mean, how does he respond to Alicia's concern? I don't know if you got the idea right now. What did she say? Or what was Pedro's solution about these concerns? She mentioned this one. Listen. I'm going to play. Just listen and then tell me.
We appreciate that. But the flip side is we want to work with fewer suppliers than we have in the past. So overall, that problem would be offset by the greater volume of work you'd get.
That was what he mentioned.
Will be offset by the greater volume of work. He appreciated that the suppliers have problems with maybe with the more work, no?
Okay, could be. Josue, any comments?
No, any comment?
No issue. Well, in this case, the answer to this one would be that they want to work. It's like the dealing of it. They want to work with fewer suppliers, as in the past.
Fewer. Okay.
So there would be
with fewer suppliers. Okay.
More work. Okay. So you can write that.
Okay. So there will be more work.
Now, knowing this one, I want you to think about mechanical fixings and non-mechanical fixings, because we can have both types actually. Now, as you can see, we have 6 different options. Look at the sandbox that you've got below in exercise B. You got 6 options. You have adhesive, bolt, clip, rivet, screw, and weld. I want you to categorize them, label them between mechanical and non-mechanical.
Mechanical system could be bolt, clip, rivet, screw, and non-mechanical fixing as well, and adhesive, because...
Oh my God, you answered it quite fast. Do you agree with that, Josue?
Yes, I agree.
Yes,
pins, X-nuts, something like that, fasteners.
Yes, I think you needed time to answer this, but you did it in seconds. Yes, the answers are okay.
Well, it's very logical. That.
Well, for you as engineers, it's logic. I was thinking about what is non-mechanical and what's mechanical. Okay, but great. Actually, those are the answers. Great. The difference between the mechanical fixing and the non-mechanical fixings. Great. So let me erase this. May I erase this one?